Hello students, so let's continue with the NCERT chapter 8, which is aldehyde, ketones and carboxylic acids. So today is a theory part 6 and the section which we will cover today is from section 8.6 to 8.6.2. This is the disclaimer. So today, objective of today's lecture is that after attending this lecture, you will be able to understand the topics which we are going to cover today. So, you will be able to write the common and IUPAC names of carboxylic acids, and you will be able to write the structures of the compounds containing carboxyl groups. Now, for your reference, I have mapped the NCERT section which we will be covering today. Today we'll cover section 8.6, which is nomenclature and structure of carboxyl group, 8.6.1, which is nomenclature, 8.6.2, which is structure of carboxyl group, and for your better understanding of the concept, we will solve an Intext question 8.6. And at last we will summarize whatever we have studied in today's lecture. Okay. So let's start with today's lecture. First is the introduction to carboxylic group. So how we will define carboxylic acids? So we have studied that these are the carbon compounds that contain a specific functional group. And that functional group is known as the carboxyl group. So the carboxyl group is represented as COOH. Okay, so this compound carboxylic acids, they contain carboxyl, which is COOH functional group. Now we have the general formula for carboxylic acid, which is RCOOH. So this formula tells you or helps you to identify the carboxylic acids based on their structure. So if you look at this formula, you will see a R group over here. Now R can represent different groups, such as it can be a hydrogen, it can be an aryl, or either it can be an alkyl group. Okay? So if you look at this structure of carboxylic acid, you will see you have this C double bond O, this carbonyl group, okay, and to one side there is a R group, and that R group can be hydrogen, alkyl or aryl, and one side you have this OH group, which is the hydroxyl group. So this is how a carboxylic acid looks like. Now let's look at the natural occurrence of carboxylic acids. So many of these acids, they are found naturally in various sources. If we see the higher aliphatic carboxylic acids, especially those with carbon chain ranging from 12 to 18. So such kind of carboxylic acids, they are known as fatty acids. Okay, and they are significant in the context of natural fats. So fatty acids, they are the key component of natural fats. So they play a crucial role in the structure and function of fats in living organisms. Additionally, these fatty acids, they exist as esters of glycerol. Now what does this mean? This means that they are chemically bonded to glycerol, forming a structure which is commonly found in fats and oils. If you look at this particular image, you will see you have one glycerol molecule, okay, and you have three fatty acids. So in glycerol molecule, you have OH group, and in fatty acids, you have this carboxyl group, okay, this is C double bond OH. So when you combine glycerol with three molecules of fatty acids, you get esters of glycerol. Okay, or we call it as triglyceride. Okay, and three water molecules, they are released, one for each ester bond formation. Okay, so you will see there is the ester bond formation. So one molecule of water is released for each ester bond formation. So when you combine glycerol with fatty acids, you get esters of glycerol, which is also called as triglyceride. Now the carboxylic acids, they are important as starting materials for synthesizing organic compounds such as anhydrides, esters, acid chlorides and amides. Okay, so each of these derivatives, they have various applications in industry as well as in the research. Now we will start with the common names of carboxylic acids. So the common name of carboxylic acids, they typically end with suffix which is called IC. The common names of carboxylic acid, they are often derived from the Latin or Greek names of their natural sources. Okay, so the common names that typically end with suffix IC and they are derived from the Latin or Greek names. Now let us look at the example of the carboxylic acids and their common names. So first we will see is the formic acid. Okay, so if you see, we have suffix which is IC. Okay, so the common names that typically end with the suffix which is the IC suffix. And if you look at the chemical formula, then it is HCOOH. And if I talk about formic acid, then this is one of the simplest carboxylic acids. So formic acid is obtained from red ants and its names come from the Latin word which is called as formica. So formica means ant. Okay, so you can see that how their name is derived from their from the Latin or Greek names of the natural source. Like formic acid, it is obtained from red ants. Okay, and if I talk about, then the Latin word is formica for ant. Similarly, next we have acetic acid. Okay, acetic acid, the chemical formula is CH3 C double bond OOH. So the R group over here is CH3 group. Okay, so it is derived from vinegar and its name comes from the Latin word which is called acetum, and acetum means vinegar. So you can see that this is showing the direct link between the substance and its source. Next example is butyric acid. If you look at the formula, then you have CH3, CH2, CH2, COOH. This is butyric acid. And butyric acid is isolated from rancid butter. And its name comes from the Latin word which is called butrum. And butrum means butter. So this is another example of how the source influences the name. If you look at the structure of all these compounds, first if you see formic acid, in formic acid you have C double bond OH and you have hydrogen. So the R group is hydrogen over here. As I can say, R, it can be hydrogen, alkyl or aryl group. In case of acetic acid, you have one side CH3 group and one side you have hydroxyl group. Similarly, in butyric acid, you have CH3, CH2, CH2 group and other side you have this hydroxyl group. So this C double bond OH will be same in every carboxylic acid. Only the R group over here will differ. It can be hydrogen, it can be alkyl or either it can be an aryl group. Now we will see the IUPAC nomenclature of carboxylic acids. So previously we saw the common names. Now we will see the IUPAC name. So the first step in naming the carboxylic acid is to identify the longest continuous carbon chain that includes the carboxyl group. Okay. So if you have look at this image, okay, so first you have to identify the longest continuous carbon chain. So if you look carefully, the carbon chain which is marked in the red box, that is the longest carbon chain. Okay, and that carbon chain contains the carboxyl group which is C double bond OOH. Now, once the longest chain is identified, the numbering of the carbon atom begins from the carboxylic carbon. Okay, so this ensures that the carboxyl group is given the highest priority in the naming process. Okay, so you will do the numbering in such a way that the carboxylic carbon gets the the numbering starts from the carboxyl carbon. So if you look at this particular image, you will see that we have started the numbering from the carboxylic carbon. Okay, so that carbon, the carboxylic carbon, got the first number, and then 2, 3, 4, 5, 6. Okay, so in this way we do the numbering, that we start the numbering from the carboxylic group. Now, the next step involves identifying any substituent that is attached to the main carbon chain. Okay, so these substituents, they are prefixed in the alphabetical order along with their position on the chain. So if you look at there, on carbon number 4 we have a methyl group, and on carbon 5 we have a OH group, which is the hydroxy group. Okay, so on carbon number 4 there is a methyl group, on carbon number 5 there is a hydroxy group. Now you will write their name in such a manner according to their alphabetical order. So if we are writing the IUPAC nomenclature for carboxylic acids, the E of the corresponding alkane is replaced by OIC, that is oic. Okay, so the E of alkane is replaced by OIC. So this helps in identifying the compound as a carboxylic acid. So if we are writing the name of this particular compound, we have identified the longest carbon chain. Then we have done the numbering in such a way that the number starts from the carboxylic group. Now if I write the name, on 5th carbon I have the hydroxy group, and on 4th carbon I have the methyl group. Now since H comes first, then I have written hydroxy first. So 5 hydroxy, 4 methyl, hexane. Hexane, why? Because we have 6 carbon atoms. And if we have 6 carbon atom, the root word is hexane. Okay. And I told you, when you are naming the carboxylic acid, for the aliphatic carboxylic acid preferably, the E of the alkane is replaced by OIC. So you will replace the E of hexane by OIC. Okay, so you get the final name, which is 5-hydroxy 4-methyl hexanoic acid. So this is how you write the IUPAC nomenclature for carboxylic acids. This was for the aliphatic carboxylic acid. Now for a carboxyl group attached to a ring. Okay, so suffix carboxylic acid is added after the full name of cycloalkane. So in the case, if this carboxyl group is attached to a ring, then we use the suffix carboxylic acid. First we write the full name of cycloalkane, and then we use the suffix carboxylic acid. If you look at this particular example, you will see that we have a cyclohexane. So the cycloalkane over here is cyclohexane. Okay, and to that cyclohexane, your carboxyl group is attached. So I told you first to write the full name of cycloalkane, which is followed by the suffix carboxylic acid. So cyclohexane plus carboxylic acid. So this will be cyclohexane carboxylic acid. Okay, is it clear? Now if I talk about aromatic carboxylic acids, then these are named as substituted benzene carboxylic acid or simply as benzoic acid. If you look at this particular example, you will see that you have an aromatic carboxylic acid. Okay, and to that aromatic carboxylic acid, one substituent, that is a methoxy group, is attached at 4th carbon. So if you are writing the name of an aromatic carboxylic acid, you use the suffix, you name it as substituted benzene carboxylic acid or benzoic acid. Okay, so if you see over here, the suffix which we use is benzene carboxylic acid or benzoic acid. Okay, so if you look here, then you will see the name of this compound is 4-methoxy benzoic acid, or you can say it is 4-methoxy benzene carboxylic acid. Okay, you can name either of it. It will be either 4-methoxy benzoic acid or 4-methoxy benzene carboxylic acid. So this is how you name the aromatic carboxylic group. Now, if you have the compound that contains more than one carboxylic group, so if you look at this particular compound, this compound contains more than one carboxylic group. So there are three carboxylic group which is in the particular compound. Okay, so how you write the name? First, you number the alkyl chain that contains the carboxyl group. So first is you will number the alkyl that contains the carboxyl group. So see, we have numbered in such a way that this is 1, then it is 2, and then it is 3. So at 1, 2, and 3, carboxylic groups are attached. Then you will use the suffix carboxylic acid for identifying to denote the presence of the carboxyl group in the compound. Okay, and to indicate the number of carboxyl group present, we use the multiplicative prefixes like di, tri, and so on. So if you see our in a compound, we have 3 carboxylic group. Okay, so we will write tri. Okay, so if you see the naming, then you will indicate the position of COOH group using Arabic numericals before the multiplicative prefixes. Okay, so first then you have to write the Arabic numericals to indicate the position of your carboxyl group. So if you look at the particular name, so first let us see one by one. First, see, we have numbered the alkyl chain, so we have 1, 2, and 3. Okay, then we use the suffix carboxylic acid and we used multiplicative di, tri, etc. So see, the name is propane 1, 2, 3 tricarboxylic acid. Okay, we have not replaced E over here because you see E is a vowel, but the next C is not a vowel. So that is why we have taken it as propane 1, 2, 3 tricarboxylic acid. So this 1, 2, 3 is to indicate the position of the carboxyl group, and we do it by using Arabic numerals. Okay, so this is for the compound that have more than one carboxyl group. Now, see, this is a table 8.3 which is given in your NCRT. So, these are the names and structure of the carboxylic acid. So, if you look one by one, first you have HCOOH. Okay, so the common name for this is formic acid. And if you look at the IUPAC name, then it is methanoic acid. Okay, you have only one carbon atom, so the root word is meth, and the E of the alkane is replaced by oic, so we have methanoic acid. Similarly, if you look at the second one, in second one you have acetic acid. The common name for this is acetic acid, and the IUPAC name, since you have two carbon atoms, so it will be ethanoic acid. For the next one, the common name is propanoic acid. Okay, for the common name we use the suffix ic. Okay, so it is propionic acid. And if I talk about the IUPAC name, since it contains 3 carbon atoms, and it is propanoic acid. Next, the common name for this is butyric acid, and the IUPAC name is butanoic acid. Similarly, for the next one, you see it is isobutyric acid. Now, if you write the IUPAC name, then you will see that on second carbon, a methyl group is attached. Okay, so the IUPAC name will be 2-methyl propanoic acid. For the next one, the common name is oxalic acid. And if we see the IUPAC name, then you see we have 2 carboxylic acids. Okay, so and 2 carbon atoms. So the root word is ethane. So ethane dioic acid. Di because it is indicating that it is 2 COOH groups are there. Next, if you see, then the common name is malonic acid. Okay, and similarly you can see its IUPAC name, it is propanoic acid, dioic acid, because since there are 2 carboxylic acids over here, so we are using the word di. So this is propane dioic acid. Okay, is it clear? Now if we see for the next compounds, then the common name for this is succinic acid. And if you read the IUPAC name, then since there are 4 carbon atoms, so this will be butane dioic acid. Similarly, for this, the common name is of this is glutaric acid. Okay, and if you see the IUPAC name, since it contains 5 carbon atoms, so it is pentane dioic acid. Okay, now if you look for this particular this aromatic ring which and to which a COH group is attached. So that similarly the name will be benzoic acid. And if I talk about IUPAC name, then we use the suffix carboxylic acid at end. So this is benzene carboxylic acid or benzoic acid. Next one, if you look, the common name for this is phenyl acetic acid. And if you write the IUPAC name for this particular compound, then if you see, it will be 2-phenyl ethanoic acid. Okay, because see, we will see this two carbon atom. One is this, we do the numbering in such a way that the carboxylic group, we prefer it first. Okay, the numbering starts from the carboxylic group. So see, the numbering will be 1. If we see the numbering, this will be 1 and this will be 2 over here. Okay, so at second position a phenyl group is attached. So this name will be 2-phenyl ethanoic acid. Similarly, if you look for the last one, the common name is phthalic acid. But if you look at the IUPAC name, then this is benzene 1 comma 2 dicarboxylic acid. Okay, is it clear? So this is how, following this set of rules, you can write the IUPAC and the common names as well as the IUPAC names. Okay. Now, if I talk about the structure of carboxylic group, then obviously it will contain the structure. It contains a carboxyl group. So the carboxyl group contains a carbonyl group. Okay, so a carboxyl group is made up of a carbonyl group which is represented at C double bond O and which is attached to a hydroxyl group which is a OH group. Okay. So if you look at the structure, we have a carbonyl group. To a carbonyl group, a hydroxyl group is attached and we have a R group. Now we have already learned that the bonds around the carboxylic carbon, they lie in one plane and they are separated by approximately 120 degree. So we are talking that this structure is a planar structure. So if you look at this diagram, it will help you to visualize. If you see at this particular diagram, you will see this is a carboxylic group and you will see that the bonds of this lie in one plane and all of them, they are separated by approximately 120 degree. If you see the angle between R and O, it is 120 degree. To this O and this O of this hydroxyl group and this O of this carbonyl, it is also 120 degree. Okay, so all you will see that the structure is a planar structure. Okay, so the bonds of carboxylic carbon, they lie in one plane. Okay, and separated by 120 degree. So if we focus on the electrophilic nature of the carboxylic carbon, so unlike the carbonyl carbon in aldehydes and ketones, the carboxylic carbon is less electrophilic. Okay, this is because of the resonance stabilization, which means that the electrons are more spread out. So because of the resonance stabilization in carboxylic acid, the electrons are more spread out, which makes the carbon less reactive to nucleophiles. So if you look at this resonating structures, so you will see that this resonance, it involves the delocalization of electrons, which stabilizes the molecule. Okay, now because of this resonance, the carboxylic carbon is less electrophilic compared to the carbonyl carbon in aldehydes and ketones. Okay, so you will see that in resonating structures, the charges are spread out in this carboxylic group. So that is why the carbon is less electrophilic. Now we will solve one Intext question. So you have to write the IUPAC names of the following compounds. Okay, so I am giving you 30 seconds to think and then we will discuss. Okay, let's see one by one. So first it is given PHCH2CH2COOH. Okay, so first you have to select a longest carbon chain. Okay, so this is the longest carbon chain. You will do in numbering in such a way that the numbering will start from the carboxylic group. So this will be 1, 2 and 3. So the parent chain, it contains 3 carbons. So if it contains 3 carbon, the root word is prop. Now if we talk about the functional group, then we have the carboxylic group, which is COOH. So carboxylic carbon gets the first priority in numbering. Okay, so this will be given first priority. So if we are writing the name of a carboxylic acid, then E of the corresponding alkane is replaced by oic. Okay. And if I talk about the substituent, then on third carbon, I have a phenyl group which is attached. So now if you see, we can simply write the name of this particular compound. Okay. So the prefix which we use over here is 3-phenyl, because on third carbon, a phenyl group is attached. Okay, so if I write the IUPAC name, then this will be 3-phenyl propanoic acid. Okay, so the E is replaced by OIC. On third carbon, I have a phenyl group. So this is 3-phenyl propanoic acid. Now let's see the next one. In next one, first we will see the parent chain. Okay, so this is the parent chain. This is 1, 2, 3, 4. Okay, so first we'll identify the longest carbon chain. So this longest carbon chain contains 4 carbon atoms. So the root word will be but over here. Now if I talk about the functional group, then we have the carboxylic group, which is COOH group. So we will do the numbering that this carboxylic group gets the first priority. That is why numbering starts from here, which is 1, 2, 3 and 4. Now, so the suffix which we use for naming the carboxylic is oic acid. Now if you see the substituent, on third carbon, a methyl group is attached to a third carbon. So the prefix which we use here is 3-methyl. And you will see there is a double bond between carbon number 2 and carbon number 3. So the primary suffix which we use is 2-ene, because it is an alkene. Okay, so the primary suffix we use is 2-ene. So if you write the IUPAC name, then on third carbon a methyl group is attached. So this is 3-methyl but-2-enoic acid. Okay, because on between second and third carbon there is a double bond. Okay, so this is 2-enoic acid. So the final IUPAC name is 3-methyl but-2-enoic acid. Now if we see the next one, if you see over here, first we will identify the base structure. So there is 5-membered ring that consists of carbon atoms. So for the 5-member ring, we use cyclopentane. And if I talk about functional group, we have the carboxylic group, which is attached to the carbon 1 of cyclopentane ring. So the suffix we use is carboxylic acid. Okay. And if I talk about the substituents, then a methyl group is attached to carbon number 2 of cyclopentane ring. So the prefix which we use over here is 2-methyl. Now if we finally combine all this and write the IUPAC name, it will be 2-methyl cyclopentane carboxylic acid. Okay, so whenever you are naming such ring structures, you write the corresponding name of the alkane, which is followed by the suffix carboxylic acid. So this is 2-methyl cyclopentane carboxylic acid. Now if you look at this particular compound, so first you will see the base structure, which is a benzene ring. Okay, and a carboxylic group is attached to carbon 1 of benzene ring. We'll do numbering so that the carbon to which a carboxyl group is attached gets the first number. So the common name which is accepted by IUPAC is benzoic acid. If I talk about substituent, then we have a nitro group which is attached to carbon 2, 4 and 6. That is ortho and para position relative to the carboxylic group. So NO2 is attached at second, 4th and 6th carbon, which is at ortho and para position to this carboxylic group. So the prefix we use is 2, 4, 6 trinitro. Tri because 3 NO2 groups are attached. So if you finally write the IUPAC name, then this will be 2, 4, 6 trinitrobenzoic acid. Okay, is this clear? So this is how, by following this certain set of rules, you can write the IUPAC names of the particular compounds. Okay, now let us summarize whatever we have studied in today's lecture. So the carboxylic acid contains the carboxylic, which is COOH functional group. Then we talked about the structure of carboxylic acid. The carboxylic carbon is sp2 hybridized. This means that the carbon atom in the carbonyl group forms 3 sigma bonds and has a planar arrangement, which influences the molecule shape and the reactivity. So the shape of the carboxylic acid is trigonal planar. Okay, so the shape results from the sp2 hybridization of carboxylic acid, which gives the molecule a flat and triangular geometry. And the bond angles in carboxylic acid, they're approximately 120 degree. So this angle is typical for trigonal planar molecules. Then we moving on to the nomenclature of carboxylic acid. We focused on the common names. So these are often derived from the Latin or Greek, which reflects the natural source of these acids. Okay, so the common name of carboxylic acids are derived from the Latin or Greek names of their natural sources. And we use the suffix is IC, such as formic acid. Then we look at the IUPAC nomenclature of carboxylic acids. So in IUPAC nomenclature, the suffix OIC acid replaces the E in the alkane, such as ethanoic acid. Okay, so thank you for your attention, students. I hope the topics which we have discussed today are clear to you. I hope you all have a nice day. Thank you.